Lesson 3 today, we'll be looking at the sine law. Uh, Pythagoras, SOHCAHTOA are fantastic tools. Unfortunately, they only work in right triangles. So we need some other formulas, ideas we can use in non-right triangles because most things aren't right, unfortunately. Reminders about sine law, you've seen this before, but just to point out some things. Okay, the sine law is here on the first page. The sine of an angle over the opposite side equals the sine of an angle over the opposite side equals the sine of the angle over the opposite side. As long as you pair up corresponding sides and angles, this should work perfectly fine. Corresponding sides and angles means the ones that are across from each other in the diagram. Remember, big letters stand for angles, so that's why it's the sine of capital A with the opposite side, small a and B and B and C and C. You don't necessarily need to have all three at one time. We usually only work with two pairs of sides and angles at the same time. Okay. There really are only two kinds of questions you can solve with the sine law. You can find a missing angle or you can find a missing side. That's all you can really do with it. And if you're finding a missing angle or a missing side, you're going to start off by cross multiplying. We have fractions that are equal to one another. Okay, so if we take a look at the first one here, I can look at this and say, hey, the 70 is definitely across from the 17. That's a pair of things that can go together. I can set that up as the sine of 70 with 17. That's a known ratio. If I want to solve this triangle, I got to figure out all the other missing sides and the missing angles. We'll label them. Okay, so big X is across from little x, big Z is across from little z, and of course angle Z down here at the bottom. I can start off with the 70 and the 17 matching up with the sine of 50 with the x. Those are across from each other in the diagram. To solve this, we're going to cross multiply like we've been doing with SOHCAHTOA. Just we've got 4 parts now instead of having 3. So x times sine 70 is x sine 70. 17 times the sine of 50. We'll write that out. X is not by itself, but we know to get things by themselves, we can divide out the part we don't want, in this case sine 70. And we'll be left with just the x. All of this can go in your calculator at one time. Just be careful. Some calculators put brackets in things, maybe a bracket there, so make sure you put the other bracket on the other side. But if you do that right, you should end up with 15.67 for the measure of x. If I want to find z, I don't have angle z or side z. I need to know one of the two if I'm going to solve this. Now the nice thing is, if we recognize things about triangles, we know triangles add up to 180 the angles. And the fact is, I already have 2 angles. So to get the third one, I can just subtract the inside 2. Okay, so we have 180 minus 50 minus 70. Z has to be 60. Okay, so I didn't have to use any fancy math for that, but just remembering some old tricks that we know from before. Now that I know the angle, I can find the corresponding side. I need to start off with a ratio that I know. So I knew from the initial one that 71 was 17. I'm going to use it again because it's something I was given in the question. I want to find the sine of 60 with its corresponding opposite side, in this case, z. Okay, this is exactly the same question we just did a second ago. Okay, cross multiply and solve, just using a different angle for part of it. So z times the sine of 70 equals the sine of 17 sine 60. Well, I got z by itself, so we're going to divide out sine 70, and that'll cancel. And we can write down z is 13.86. And then you've found x. You solved the entire triangle. That's how you solve missing sides. Okay. If you look at the second one, same sorts of ideas. Okay, I want to solve this triangle. I have to have a known pair. And looking at it, I can see the 32 has to go with the 43. There's no choice on that. But I have a little bit less information this time. Okay, so it means I may have to be doing something slightly different. Okay. The first thing I can do, I'm going to label my side. So that's K, across from big K. I don't know angle K, I don't know side K. I can't use the idea of they add up to 180 because I only have one angle. So I'm going to have to solve something else. I know that the L is across from the 37. So I can sign L with 37. The only thing I'm missing is the L there, so I should be able to solve this. Again, fractions, let's cross multiply. So 37 times the sine of 32 will be 43 times the sine of L. Okay, basically what I did last question. Again, I want to divide out the parts I don't want. In this case, I'm going to divide out the 43. I am not dividing out the sine because the sine is attached to L. It's the sine of that angle. I can't divide that part out. All I can divide out is the 43 part. I'll be left with sine L on the right. And when I put all that stuff in my calculator on the left-hand side there, I end up with 0.4559 and a whole bunch of other numbers. Okay. I want to find that angle. Sine L is equal to this angle. Well, to get L, I need to do an inverse. Okay. Remember, whenever we want to find angles, okay, SOHCAHTOA, sine, cos, tan, all those things, we use an inverse whenever we want to find an angle. An inverse of whatever that ratio happened to be, which is still in your calculator. So you should be able to press just second sign or shift sign. You don't really want to have to retype the entire number. Okay. And you should get 27.1 degrees. Okay. That's the only other kind of question you can do with the sine law, finding a side or finding an angle. Okay. So we've got L, 27.1. Kind of handy. We'll put that into our diagram just so we know we found it, and you'll see why in just a second here. Because if I want to find K, we can go back to the idea that, hey, K has to be 180 minus the 32 minus the 27.1 we just found, and we'll end up with a K value of 120.9. Obviously, the diagram is not to scale there, so don't worry about that part. Okay. It's kind of helpful to put things back in your diagram after you've solved for them. Okay, all I'm missing is the small k, and we can solve for that. Give it a try right now. It's like what we did in example number 1. Okay, you should be able to do that one yourselves. Take a ratio that you know, and a ratio you want to find. Sine of k, 120.9. It's going to go with little k. Okay, we're going to cross multiply and solve. K sine 32 equals 43 sine 120.9. I want to get k by itself. I'm going to divide out the part I don't want. In this case, I can divide out the sine of 32 because I know both parts, sine and the number. Okay, sine 32. I'll put that all in my calculator at one time. If I do it right, k should come out to 69.6. Okay, we've solved that triangle.